Earth science. I'm embarrassed about it. Okay, we're gonna talk about the atmosphere.
That's so awkward.
It is so awkward. It's nice though. It's a nice kind of awkward. So we're talking about the atmosphere. The objective is describe the composition and layers of the atmosphere. So write that down too. Describe the composition and layers of the atmosphere. Describe the composition. What's the word composition mean? Uh-oh.
Isn't it like the makeup or something?
Yeah, the makeup of something. And what's the word layers mean? Uh-oh.
Like, stuff like
Yeah, it was stacked on top of each other. Okay. So, the atmosphere in general is what we're talking about. In fact, this whole lesson is about, this whole chapter is about Earth's atmosphere, but this specific lesson is about what your book calls the basics of the atmosphere. So, the first thing we're talking about is the composition. As we said, the composition is what the atmosphere is made out of. Do you know? I mean, primarily, the atmosphere is made out of what thing in general? Okay, yeah, nitrogen as an element, but what type of substance in general makes up the atmosphere? Gas. So the atmosphere is, by definition, we can say the atmosphere is like a layer of gases around Earth, right? Why is it there? What keeps it there?
Gravity.
The gravity. Yeah, gravity on Earth attracts some gases to the planet, and so they stay. Do you know, just kind of as a side note, do you know what the atmosphere of like Jupiter and Saturn is made out of mostly? Yeah, they're big, right? You know they're big. Those are big planets. They're made out of hydrogen and helium, which we talked about, I think, once either in here or in chemistry. But if you have a helium balloon on Earth, what's going to happen if you let go of it? Yeah, it's going to float away, and eventually the balloon will do what? Pop, and then the helium that was in the balloon will do what? Yeah, go into outer space. So Earth's gravity is not strong enough to hold hydrogen and helium to the planet's surface. Whereas on Jupiter and Saturn, because those planets are bigger and therefore have more gravity, their atmospheres are mostly hydrogen and helium because the gravity is strong enough to hold them. Maddie?
How long does if you did that, how long would it last?
I don't know. How long do you think a helium balloon would take to float up to the atmosphere?
Google it.
Okay, sometime Google it, but you're gonna have to. Would you sit in between Natalie and Darius for an hour, or maybe you can just sit in that little blue chair there? It's a nice blue chair. Anyway, so yeah, the atmosphere is made largely. It's made entirely of gases. That's not quite true because there is some like liquid water. What do we call it when liquid water is suspended in the atmosphere? A or an cloud. It's a cloud. But the Earth's atmosphere is composed mostly of the element nitrogen. What's the chemical formula for nitrogen? N2. Good job, Levi, who has never taken chemistry. I was looking at you, Tyler, because you have taken chemistry, and so do you. But nitrogen, which is N2, makes up about 78% of Earth's atmosphere. The next major component is oxygen. What's the formula for oxygen, not Levi? O2, because these things are diatomic atoms, so when they're found in nature, they are combined with themselves, and this makes up about 20% of Earth's atmosphere. Oh, your book says 21%. 21%. It does vary a little bit, and we'll talk about why in a second. The next biggest are argon, carbon dioxide, which is CO2, and then water, and then there's something called trace gases. And the trace gases just means that there's very little of them. And so all together, these things make up what percent? Well, 78 plus 21 is 99. So what percent must all these together make up? About 1%. The one that varies the most is water. So water can make up between 0%. Where might there be 0% water in the atmosphere? Like where on Earth might there be 0% in the atmosphere? No, not necessarily. What? Yeah, where might there be 0% water in the atmosphere? Where might there be no water in the atmosphere at all? Or maybe not none, but very close to none.
Maybe at the very top?
Would it be around the poles?
No. Where's there little water?
Desert?
A desert. Yeah, in a desert. So maybe in a desert the atmosphere has almost 0% water, but it can make up to 4%. Where might we find almost 4% water in the atmosphere? In humid areas like the rainforest. Or maybe when it's raining outside here even, it might be close to 4%. So since this varies so much based on how much, what do we call it when there's water in the atmosphere? That's called the Take your hat off.
Hydrosphere?
Yes, it's part of the hydrosphere, but when there's water in the air that makes your hair crazy,
Humidity?
humidity, yeah. Humidity. But so the amount of water in the air can change, and so obviously, if this is going to be 4%, then these two can't add up to 99% because 4% plus 99% is 103. So these both can go down. Like just depending on how much water there is, these can vary a little bit too. There's still the same total amount of these, but relative to the total amount of atmosphere at large, if the water's more, these have to be less, right? Do you see what I mean? So all of these kind of have some wiggle room in them, but this is mostly true. This is on average true for the atmosphere. This, when it's in the atmosphere, it exists in what state? Water what?
Vapor.
Water vapor. Can you see water vapor? We talked about this yesterday. No. Water vapor is invisible. So a cloud is not water vapor. What's a cloud made out of?
Liquid.
Yeah. Clouds, write this over here. Clouds are liquid droplets, or what else could they be? Ice crystals suspended in the air. And the reason I point this out is because, well, for one thing, I thought this when I was in elementary school, and I think a lot of elementary school kids maybe do, and maybe you did before this, that when we talk about water vapor being in the atmosphere, you think, oh yeah, that's just the clouds. But that's not the case. Water vapor in the atmosphere is what we call humidity. And then the clouds are not water vapor. The clouds are water in other states. We don't, I guess probably technically even, since the atmosphere, the definition of atmosphere is the gases that surround planet Earth, we don't consider the clouds to be part of the atmosphere. They're contained within the atmosphere, just like you are, but they're not, they don't make up the atmosphere. I'm going to draw a little cloud over here, and a little sunshine peeking out from behind it. Look how shy he is. Stupid. Okay. You need to have memorized, I don't know, that's maybe too strong a word. You should know the order in which these go in the atmosphere. Definitely these two and then these as a group. And you should probably know about the percentage. Like it's not good enough just to say nitrogen then oxygen and then think, oh, it's 60 and then 40, because it's not, right? This one especially is important to know that the atmosphere is about 20% oxygen. A lot of people think that the atmosphere is all oxygen. Like a lot of people just think air and oxygen are synonymous. That's not the case. This whole thing, all of this together, is called the air. What type of matter could we consider the air to be? It's not an element, right? It's not really a substance. What is it? It's a mixture. Yeah. The air is a mixture of gases. Okay, let's talk about the layers of the atmosphere now. I'm just going to draw a little diagram over here. Can you see that okay on the camera? Yeah, whatever. So here's Earth's surface. Earth's surface. Oh, I should move my sun and cloud up so that they're in the atmosphere now. Oh, well, he's a little sad now. And really, the cloud should not be anywhere near that high up. Let's move it again. The sun's still way over here, though. Now he's extra sad because he ain't got no buddy. And he's really misshapen. Okay, so here's the Earth's surface, right? What goes on the Earth's surface? Well, Levi's here. Skyscraper.
Jesus tall.
Cactus. All the stuff that you're familiar with is in one layer of the atmosphere closest to the surface. I'm also, if you look at this chart on page 285, this is what I'm going off of. And this area down here is called the troposphere. Troposphere. This is where all the weather happens, or the vast majority of the weather. Some weather originates in higher layers of the atmosphere, but all the weather that we encounter on a daily basis, or that we think about when there's like a hurricane or a tornado, all that occurs in the troposphere. You and the weather happen here, right? You happen here, the weather happens here, cyberbullying happens here, chocolate milk happens here. Everything you're familiar with in your entire life takes place in this little area of the atmosphere called the troposphere. The next layer up is called the stratosphere. You've heard of the stratosphere, I'm sure. Stratosphere. You might hear it as like an expression like, Oh man, he hit that home run into the stratosphere. I know about sports. And the stratosphere is just it's a layer of Earth's atmosphere above the troposphere. Above the stratosphere comes the mesosphere. Above the mesosphere is the thermosphere. And then I've left the top off of this because the exosphere, there's no definite line, like the atmosphere doesn't just stop at some point in outer space, right? So the exosphere is what we call the layer that's kind of the gray area between what's Earth's atmosphere and what's outer space. The general consideration is that I think it's 100,000 meters, maybe 100,000 kilometers is considered space, and that's the thermosphere, yeah. And then outer space begins somewhere above the exosphere, maybe 1,000,000 meters into space, so 1,000 kilometers. But there's no definite line, right? There's no place where if we take one more step, we're going to be in outer space, right? Well, not step. If we take one more rocket fire, we're going to be in outer space. It just kind of fades into space, right? So the atmosphere in general, as we go up, what happens to the atmosphere? It gets what? Thinner. Did you say thinner?
No.
Bigger?
Bigger.
Well, yeah, it takes up more area because it's a bigger circle, right? But also it gets thinner. Good. I can't believe you got that. Thinner. Yeah, it gets thinner as we go up, right? Thinner here meaning
The air.
yeah, the air, there's less air. All of these things, there's less of them. They're still roughly in this ratio, but there's just less of them in general. So the atmosphere thins going out. And why is that? Well, where does gravity act the strongest? Towards the Earth's...
Surface.
Yes, but more specific. Well,
Core.
that's true. The Earth's core is where we consider that gravity, the origin of the gravitational field on Earth. And so the nearer the core, the stronger the gravity. And so here, where the atmosphere is the closest, the more gases can be compressed into that. So here's where you live. Up here is where other stuff happens. What happens, do you think, to the temperature as we go up?
It's cold.
Yeah, it's not exactly that straightforward. So look at the chart on page 285. You can see they have here on the x-axis the temperature in degrees Celsius. You see that on 285? And you see, as we go up in the troposphere, what happens to the temperature? Really quite rapidly. Yeah, in the troposphere, what happens to the temperature? Just in the
It
troposphere.
goes,
What's that yellow line showing?
It goes to negative.
Yeah, it decreases, right? Yeah, it goes down. As we go up in the troposphere, the temperature decreases, right? The highest mountain is shown in this little diagram, Mount Everest there. That highest little peak there represents Mount Everest, and that's to scale, just that little bit. And so as we go up, and you're aware that it's cold on top of Mount Everest or in any mountain, and that's because as we go up in the troposphere, the temperature decreases. But then as we go up in the stratosphere, what happens as we go up in the stratosphere? Look at that. It gets warm. It gets warm again. As we go up in the mesosphere,
it gets cold.
it gets cold again. And then why do you think it goes to a gajillion at the end of the mesosphere? What did I say? What did I say is 100,000 kilometers? That's where space begins. So there are very few particles there at all, but the ones that are there are moving very quickly, right? And remember, the temperature is a average of the kinetic energy of the particles, right? And so there are very, very few particles at all in the thermosphere and above, but the ones that are there are moving very quickly. So we don't really talk about the temperature of space because it doesn't really exist. There's nothing there to measure the temperature of. Do you see what I mean? So you should kind of be familiar with the general trend of temperature as we go up. So in the troposphere especially, it gets cooler as we go up. Then in the stratosphere it gets warmer again, and in the mesosphere it gets cooler again. Do you have questions about the layers of the atmosphere? You have to have these memorized as well, and that's just in order, right? You don't have to know like the in-depth facts about them. You should know that you live in the troposphere, where the weather also exists. And the last thing we're going to talk about before we're done with this video is there are, this is something we talk about both in 8th grade and in physical science, so you should be familiar with this. But we're going to talk about the ways that heat can be transferred. So where does all the heat, not all of, but where does almost all of the heat that we have here on planet Earth come from?
The sun.
The sun. So good thing I drew my sun up there. There. So all the energy, all the heat energy that we have on planet Earth comes from the sun, and heat energy can be transferred in 3 ways. Why'd you smack him?
Who's sleeping?
There are 3 ways that heat energy can be transferred. 3 ways heat energy can be transferred. You know what they are? You remember this at all?
No.
Well, kind of you do. What's one of those, Skyler? What's a real one? What's
Thermal.
radiation is one. Radiation is one. What's another one?
Friction. No.
Radiation.
Thermal.
Conduction.
Conduction.
Convection.
And
Convection.
I just
Right.
had them.
So friction, a couple people said that. And friction is what we call it when kinetic energy, because something's moving, like your hands, becomes thermal energy. But it's not really a way that, of thermal energy transfer. It's not a specific way. Which one of these will we call it? When we rub our hands together and it warms up, that's mostly which one of those 3? Radiation, conduction, or convection? Conduction. Is that what you said? Because 2 of them sound the same. Good. That's what I thought.
So did I.
So, radiation is just where the heat emanates from some point source. Have you ever heard of a radiator? There's a couple different radiators I can think of. What's one radiator? There's one in this room, right? There's a radiator in here, and its point is to radiate heat out from it, right? The heat comes out from a single source. So heat moving through space as radiation. Well, I can't say as radiation, as electromagnetic waves. Which of the electromagnetic waves carries the most thermal energy? Do you know? First of all, what are some examples of electromagnetic waves? They're all the different kinds of light. What are the different kinds of light? Yeah, there's infrared, ultraviolet. What are some other ones? Visible light that you can see with your eyes.
Is it no?
Gamma rays, X-rays, microwaves, and radio waves are the other
I
ones.
would say
But anyway, of those, infrared light carries the most thermal radiation. And so like when you go into Walmart, they have that thing that makes you feel warm. You ever experience that? Like you go in the door and there's like a blast of warm air. They have an infrared heater up there that makes it so that when you come in, all the heat that's inside Walmart doesn't get out and go in the parking lot. Anyway, so radiation is when it's carried through space as electromagnetic waves. And this one's important because this is the only one that can move through a vacuum. Move through a vacuum. So, nope, not like your vacuum cleaner, like like the vacuum of space, meaning there's no matter, right? And so all the energy from the sun moves to Earth through radiation, right? Because it's going through a vacuum. There's no atmosphere there. Conduction is heat transfer when objects are touching. What's an example of conduction? Yeah, when you touch a hot pan and it burns your little handy, that's conduction, right? Because the heat transferred from the pan to you because those things are touching. And then convection is heat transfer through a fluid as density changes. You remember convection, surely. We did a little lab about it in, I can't remember if it was physical science or in 8th grade, but we had our beaker on our hot plate. So where's the heat source here? The hot plate. So where in this beaker of water, where it gets warm first?
The bottom.
The bottom gets warm first. And when it's warm, it becomes what? What does it do when it's warm? It floats up, right? And then when it gets to the top, what's it do up here?
Oh.
Because it has done what? You're right. Because it cools down, because it's near the top, right? Now it cools and falls back down. So it makes a circular pattern, right?
Mr. Kyle, what does that say? As density what?
As density changes. Changes. I'm going to write it the exact same way the second time. As density changes. That might even be worse. So this one's extremely important to us in earth science because where else does convection occur? That's going to be super important here in a little while. So it occurs in the beaker on the hot plate. It occurs in water in the ocean to some extent. What else though? Where it's really important for plate tectonics because this occurs in the what?
And like the layers.
In the layers. Which one?
The cracks.
The mantle. Thank you, Levi. The mantle. You got all of them. One that was right. So this occurs also. This occurs also in the mantle. So that's good. Bye.